Okay, so to start solving this, let's figure out how much total heating each one of them receives. So since they're on identical heating pads, we know they receive the same amount of heating. So we know a lot more about the liquid because we know what actually happens to it, what temperature it gets to, if it boils or not. So let's use that. So there's actually two things we need to calculate the total heating, because it gets heated in two ways. First, it goes from 300 Kelvin to 400 Kelvin, and that's just using our Q equals MCAT equation, right? This one. Next, it goes from a liquid to a gas, and that uses our Q equals ML equation. Okay, so let's use these. So let's plug in our numbers. Well, what's M? M is 100 grams, pretty easy. Q equals, what is our C? Well, we're given, it's 5 joules per gram degree Kelvin. Or not degree Kelvin, just Kelvin. And then what's our change in temperature? We're going from 300 Kelvin to 400 Kelvin, so it's 100 Kelvin. Multiplying this all out is 50,000 joules. 50 kilojoules. Okay. Now let's go here. We just need two numbers here. L is our latent heat of vaporization, or how much energy per gram it takes to boil it off. So just two numbers, just 100 grams. Again, Q equals 100 grams times 1,000 joules per gram. Perfect. And this is 100 kilojoules. Not 1,000, 100 kilojoules. So to get the total heating, we need to add these two because both of them happen. So we're going to get 150 kilojoules of total heating. So that's our total heating, and that's also the total heating for the metal. So let's now apply that to the metal. Now, since it doesn't melt, we can just use the Q equals MCAT equation. But we're actually looking for delta T. We're not looking for Q. We know Q. Q is 150 kilojoules, or 150,000 joules. So 150,000 joules equals MC delta T. Let's move this over here and get the 150,000 joules over MC, or over 10 grams times 3 joules per gram Kelvin, equals delta T. And so we get 150,000 divided by 30 equals delta T. And so delta T is 5,000 Kelvin. So since we started at an initial temperature of 300 Kelvin and we go up 5,000 Kelvin, that means that we ended at a final temperature of 5,300 Kelvin, which is obviously quite high.